Japan's Hayabusa 2 spacecraft has successfully deployed a third lander onto the rugged boulder-strewn surface of the asteroid Ryugu. Jointly developed by the German and French space agencies, the 10-kilogram Mobile Asteroid Surface Scout, or MASCOT, collected images and data on Ryugu's composition and geology. MASCOT was ejected from the Hayabusa 2 orbiter at an altitude of 51 meters, descending in a slow-motion freefall to the surface, touching down some 20 minutes later. Its successful deployment came just days after Hayabusa 2 dropped off two biscuit tin-sized probes known as Micro-Nano Experimental Robot Vehicles for Asteroids, or MINERVA 21A and 21B. But unlike the MINERVA probes, which are still scampering around the 150-metre-wide asteroid, MASCOT was only designed for a brief 16-hour lifespan. Still, it managed to continue operating for 17 hours, hopping across the surface collecting new data before its batteries finally ran out. After its initial automated reorientation hop, MASCOT ended up in an unfavourable position. Mission managers then commanded another hopping manoeuvre, placing the rover in a more favourable position using its swing arm for momentum and positioning. From its new position, MASCOT successfully completed a measurement sequence using all its instruments over one asteroid day and an asteroid night. Scientists also recorded image sequences using its onboard camera, which will be used to generate stereo images of the surface. MASCOT then moved several metres to a new monitoring position to continue its scientific mission. Finally, and seeing that the lander rover still had some battery power left, researchers undertook a much bigger jump to a new location. In addition to the images, a radiometer, a magnetometer and a spectrometer aboard MASCOT provided measurements on temperature, magnetic properties and the composition of the regolith. With each Ryugu day lasting 7 hours and 36 minutes, mission managers in Cologne, Germany were able to see the sun set 3 times during MASCOT's mission. They say all of MASCOT's data was successfully uploaded to the Hayabusa 2 mothership as planned before its mission end. Hayabusa 2 then returned to its parking orbit at an altitude of 20 kilometers above the asteroid's surface. The Hayabusa 2 mission was launched aboard a Japanese H-2A rocket from the Tanegashima Space Center south of Tokyo on December 3, 2014, arriving at the near-Earth object asteroid Ryugu some 300 million kilometers away in June 2018. The 609-kilogram spacecraft is spending 18 months studying the asteroid's chemical composition, structure, early history, and evolution. The probes carrying multiple scientific payload instruments designed for remote sensing and sampling, including optical navigation cameras, a near-infrared spectrometer, a LiDAR light detection and ranging instrument, a thermal infrared imager, and laser rangefinders. And of course, Hayabusa 2 is also transporting 4 lander rovers designed to investigate the asteroid's surface. As well as MASCOT, there are the 3 1-kilogram hockey puck-shaped rovers known as MINERVAs. With MINERVA 21A and 1B successfully deployed prior to MASCOT's descent, only MINERVA 2-2 is yet to be deployed, and that won't happen until next year. By the way, in case you were wondering, there was an original MINERVA 1. It flew aboard Japan's first asteroid sample return mission, Hayabusa. However, Hayabusa failed to carry out its full mission to the asteroid 25143 at Ikawa. The MINERVA 1 probe failed to land on the 350-metre-wide potato-shaped asteroid, instead going to orbit around the Sun. And the Hayabusa mothership also experienced problems, failing to collect the samples expected, instead only managing to gather up some asteroid dust. But the dust was successfully returned to Earth, being ejected in a sample return capsule which successfully parachuted down into the Woomera rocket range in outback South Australia in 2010. Needless to say, JAXA, the Japan Aerospace Exploration Agency, is hoping for better things with Hayabusa 2. Towards the end of its mission, it'll use high explosives to fire a 2-kilogram copper impactor into Ryugu as a small deployable camera called DCAM-3 is released from the mothership to collect imagery of the impact from a distance of about 1 kilometre. During the impact sequence, the Hayabusa 2 mothership itself will retreat to the far side of the asteroid to protect it from any debris as the impactor slams into the surface, producing a crater. After all the dust has settled, Hayabusa 2 will then return to the impact site, drop down to the asteroid surface and collect ejected debris blown out from below the crust. Scientists believe that by getting debris from below the crust, it's less likely to be exposed to the some 4.6 billion years of contamination that material on the surface would have been subjected to. The orbiter is then scheduled to depart Ryugu in December 2019, swooping past the Earth a year later, where it will eject its sample return capsule, which is designed like its predecessor to parachute down into the Woomera rocket range.